Okay, everybody. This is the Hammondsport1 case. We're going to talk about that today, and I'm going to share the screen with you. Here we are, of course, at the Moodle room for Management 3603, and the Hammondsport1 is, of course, due on the 9th, pardon me, the 5th. Pardon me, excuse me. Hammondsport1 is due the 7th, which is Friday. And I ask you to use GoalSeek to obtain a probability of waiting time to 0.055 by changing the largest value for inter-arrival times. And then I also ask you to use GoalSeek to obtain a maximum waiting time to 9.5 by changing the mean service time. Now, we're going to take a look at this, and Hammondsport1 is shown on page 567. And as I mentioned, you need to really review pages 561 to 572 in developing what we call waiting line simulation. Now, I also want to point out to you, I went over here to the middle room to show you, I have an article here about the ROI on analytics and the return that we get by using them. And then here is a nice the PDF that deals with why we won't wait, customer satisfaction profits. And by decreasing time, we can increase satisfaction and profits. And then a link to an article on how long will customers wait for service. So this is a vitally important topic. And again, we're going to use, as it's talked about in class this week, we're going to use a simulation to try and find out what our waiting line times will look like to try to make some kind of reasonable guesstimate or forecast on how things will look before we actually conduct it. Now I'm going to open up the Hammondsport1 file, and that's over in chapter 12, so open that up. Let's take a look at it. This is a bank, and they have one ATM. Okay, that's why they call it Hammondsport1. And they have the inter-arrival times, okay, and the largest value, the smallest value, and then a mean of the service times, the normal distribution. They're assuming that inter-arrival is uniform and that the service times are normal, and we see the mean and the standard deviation. Now, in the event that you may not quite get this, they walk you through the flow chart of the simulation there on page 564, and they also give you a definition of what inter-arrival times are, what arrival time is, start time, wait time, service time generated, the completion time, and the system time. You can see that here in this cell, and so I'm going to click here on cell B16, and this is the inter-arrival time, okay, and there's been no one customer there, so the inter-arrival time is 2.0, okay. The person arrived at 2.0. It took their service start time, so there was no one in front of them, and so they came in immediately and got served. That's shown here. They didn't have to wait. The service time was 2.1, and the completion time was 4.1. And that is the time they started the service and the time that the service actually started and the time that the service occurred. So we're breaking their whole experience down into chunks of time, okay? And then we want to look at the time they spend in the system. Now you'll notice when I got through here just a minute ago, these figures all changed, okay? And these are all volatile figures. Now here we have the second customer has an arrival time of 2.5, inter-arrival time 2.5, arrival time at 3.4. So they came in as the second customer, and the first customer had been there 0.9. They're there, and they've come in at 2.5, so the arrival time at that point is 3.4. That's when they got there. That's their service start time. They didn't have a wait either. They did not have to wait. And you can see how it just correspondingly moves itself on. Now up here at the top, we see the smallest value for an inter-arrival time, largest value, okay, and then the mean and the standard deviation, okay. And as we scroll down here, we're going to see some summary statistics. We see the number of people waiting, okay. and we count that, and notice we use the count if, E116 to E105, okay? And notice again now, look, one of the things you'll need to understand is this is frozen, okay? There are 1,000 arrivals here. But that row is frozen so we can scroll through. So we have 474 people waiting in the line. The probability of being put into a waiting line is 0.52, and that is E1018 over 900. So it's the number of those waiting, and they're 900 here. So 474 of the people out of 900 who come in are waiting. So your odds of waiting or your probability of waiting is 0.52. The average waiting time, that's computed from E116 to E105. And then the maximum waiting time, we choose the maximum from that, or E116 to E105. And we're looking at waiting time. Utilization of the ATM, it's the sum of F116, okay, the service time to 105 divided by the completion time. So the utilization is a quotient, if you will, of the service time divided by the completion time, and that only makes sense. So we had that number there. So about 75, the ATM is utilized about 75% of the time. The number of those who waited more than a minute was 116, and that again, we just used the count function for E116 to E1015. And then we computed the probability of waiting is greater than a minute. It was just simply E1023, that's the number of waiting, greater than a minute, divided by 900. So the probability of waiting more than a minute is 41%. Now you notice something here. If you look at the probability of those who are waiting more than a minute with 0.41, or basically, we could call it, it's roughly 0.42. If you look up here, the probability of waiting is 0.59. So you have about a 59% chance you'll be waiting, and overall, then you have the probability of waiting greater than a minute is 0.41. So if you assume those are dependent events, the probability is one thing, versus if you assume they're independent events. And that can be debatable because we don't have control over who arrives. Okay? Now, what I'd ask you to do, first of all, was to use GoalSeek to obtain a probability of waiting of GoalSeek to obtain a probability of waiting to 0.55 by changing the largest, okay, value for inter-arrival times. All right? So let's look at this for just a minute, okay? And I'm just going to sit here. I'm going to grab a sheet of paper. All right? And the probability of waiting, and that's going to be cell E1019. Okay, that's the probability of waiting. And the largest value for the inter-arrival time is B5. Okay? So we're going to use GoalSeek here. And I'm going to click on Data. Come over to What If Analysis. I'll click on GoalSeek. And I'm going to use GoalSeek to set the cell E1019. to 0.55 by changing cell B6. Pardon me, B5, excuse me, B5. And we'll run and see what we get. Okay. Now, in this case, the largest value was 5.316,207. And we find that the target value, we'll click OK, we'll accept that, is 0.55. Now, I had created a screenshot when I had done one of these, so I'm look at the solution screenshot, okay? And here I had run this. This is the first page, excuse me. And here, notice I had gotten a 0.55. And I got a largest value of 5.447. And I got a probability of weighting of 0.55. So on GoalSeek, the largest value when I ran at that time was 5.447. Let's look at where we are here. Here this time, we're at 5.31. We obtained the probability of weighting. Now, here's the point, okay? You'll notice as we flip through these data change, all right? And they are volatile, and they're intended to be volatile. They're random numbers, okay? And basically, because they are, we're looking for a range of values, and I talked about this in class the other day. The top and the bottom, and where are the possible outcomes, the largest, the smallest, and you'll see this on the inter-arrival times, okay? And we assume a uniform distribution. The smallest value, obviously, is 0. The largest value, 5.316,207 in this case. You notice as we change, the values all change, but they all still correspondingly work themselves through. In this case, I'm back to a 5.5056. Now, I had mentioned that I wanted you to take a look at pages 561 to 572. I'm going to take this opportunity, okay, to just show you, for example, over on page 568 in your text, you want to take a look at this figure 12.6. And they show you the number of customers waiting, 1 minute or less, and then a percentage of customers who had a waiting time greater than a minute. And then it walks itself all the way out to even those customers who had a waiting time greater than 6 minutes. And they show you that distribution and how rare some of those would be. So we're all about looking at this uniform distribution and looking at it from the standpoint of where can things go. Now, again, let's just do this again. And just for grins, let's click on data analysis. Let's look at solver. Okay, and we didn't use it here to set that figure, but we can use the GoalSeek to simulate the data. Now you say, where did you get the random numbers? And let me point this out again. That's why these numbers look jumpy. They're what we call volatile, okay? Look at the formula, equal B4 plus RAND. I talked about this in class, RAND meaning the RAND function. So we're going to select B4 plus some random number times B5 minus B4. Now the interesting thing here is that we just chose the RAND function, okay? I'm going to go over here for just a second. I'm going to click in this cell, equal RAND, so we can see the function has no arguments. It returns a random number greater than or equal to 0, and less than 1. Evenly distributed, evenly distributed, it changes on calculation. Okay? Now, if we use rand between, that's a different matter. But in this case, we're just taking the smallest value times some random number between 0 and 1. And that gives us the number that we multiply times B5, the largest value, minus B4. So we take that largest value. The largest value will change because we have multiple numbers. So we're taking the difference. Basically what we're doing is here, we're taking the smallest value, some random number, okay, times B5 minus B4. And B5, obviously B4 is going to be as smallest as 0. And so anything we multiply times a random number, it's going to end up 0, okay? But we're going to add 0 to that number. I'm sorry. In the first piece of this equation, B4 plus some random number between 0, so we'll add 0 up to 1, and then that's multiplied times B5 minus B4. And that's how we get that largest value. My apologies. Now, again, we can compute the number of weighting, the probability of weighting. Now, the second piece of this is I ask you to use goal-seek to obtain a waiting time of 9.5 by changing the mean service time. So let's look at this for just a minute, okay? And let's find the cell for the maximum waiting time. And the maximum waiting time is going to be right over here. And that's going to be at cell 1021, okay? And then we're going to look at the mean service time, which will be B8, okay? So we're going to use goal-seek, and C1021 is the maximum waiting time. And the mean service time is B8. So we'll click on what if analysis. We'll do the goal-seek. All right. And I'm going to set cell C1021 to 9.5 by changing cell B8. I'll let it run through. You can see the iterations it's going to work through as it works through these random numbers. It stopped. And the target value is 9.5. The current value is 7.8. Now, we'll just stop at that. Now we can run it over and over, okay? And okay. I'll do the goal-seek again. I'm going to set that to 9.5. Okay, by changing cell B8. Run it again. See their target value and then the current value it's at and the iterations. And the target value was 9.5, but we have a current value of 21. Okay. Now I want to open up a screenshot that I did here. And here I had the target value of 9.5. Okay. And I got to a current value of 9.4. So if you look there, I've got a maximum waiting time of 9.4. And that's C1021. That's the max waiting time. I'm very close to my target there. The target value is 9.5. And the mean is 1.9413446. Okay, I ran this a few times to get this. The largest value appears 5.31627. Notice how those inter-arrival time impacts the average waiting time. As the largest value of the inter-arrival time goes up, the average waiting time goes up as well. You can see that in math just as it runs across the table. So I'm going to come in here and I'm going to put those values in. Let's see what we get. And I should make sure that I have the largest service time. And we'll just try these. And you can see what you get. You can see you would need to use the goal seek and run several iterations of it to get that solution. And you can see from the screenshot. Well, it becomes an issue where you just run the iterations, you continue to run, and you can go in and you could go into the settings in Excel and increase the number of iterations if you care to do that. But typically it will run 100 iterations. The whole point of this is that we can, here we have 1,000 service instances. We simulate the whole customer experience. We break it down to the point they arrive, the amount of time it took for them to get served. And notice this, the service start time is 5.3, the arrival time is 5.3, the inter-arrival time 5.3. Notice this, the service time is 6.5. They arrived at 5.9, so their inter-arrival time is 0.6, and that equals that difference. And the service time 1.7, and you can see. And we're concerned about how long were they in the system, how long did they wait, and that's why we compute these metrics. The number of people waiting, how many people waited, the probability of people waiting. In this case, it's about 50-50. The average waiting time, the maximum waiting time, the utilization of the UTM. So it's utilized about 70% of the time. The number of people waiting greater than a minute, and the probability of waiting greater than a minute. And you might say, okay, well, that's not acceptable. I want 20%. So then you have some choices. If this is all arbitrary, in other words, how long it takes for the ATM to operate to conduct a transaction, which it is, it's a machine, then you're probably going to have to build more ATMs. But at least you know if you have some limitations with the one ATM. Well, folks, that's it for Hammondsport1. I hope you have a good weekend, and I will make this visible as well as the spreadsheet and this Zoom recording once the assignment due period is passed. Have a great one. Take care. Back to the meeting here. And we'll pause. And we'll stop sharing. And we'll stop the recording.